Ratio, proportion and variation. Ratio and proportion. Introduction of ratio. Order relation between ratios. Properties of equal ratios. Theorem of equal ratios. Proportion and continued proportion. Miss Sonali were teaching ratio, proportion and variation to her students. Sanjay scored 36 runs and Raju scored 9 runs. How will you compare their runs? Sanjay scored 27 more runs than Raju scored. Very good, students. Sanjay scored 4 times the runs Raju scored. Right. Again. Raju scored 1/4 of the runs scored by Sanjay. Very good. In the last sentence, how we compared runs? We compared runs scored by Raju and runs scored by Sanjay by writing in division. Therefore, runs scored by Raju upon runs scored by Sanjay is equal to 9/36, that is 1/4. Comparing two quantities of same type by division is known as ratio. Always remember, student, to compare quantities, both quantities should be of same unit. We define ratio of two real numbers, A and B, as if A and B and K are non-zero real numbers such that A is equal to BK, then K is the ratio of A and B. The ratio of A and B is written as A is to B, which can also be written as A by B. Dear students, don't mix fraction and ratio, okay? The meaning of both is different, though the way of writing of both is same. Now let us learn some properties of ratio. The ratio remains unchanged if both the terms of ratio are multiplied or divided by the same non-zero number. If ratio AK by BK is equal to A by B, then ratio A is to B is the simplest form of ratio. For example, the simplest form of ratio 15/18 is 5/6. That is, ratio 5:6 is the simplest form of 15:18. Order relation between ratios. Now, can you tell me which ratio is greater? To find which ratio is greater and which is smaller, we have some simple rules to study. Now, consider two ratios, A by B and C by D, where A, B, C and D are all real numbers. Now, let us cross multiply the ratio and we get A into D and B into C. If A into D is greater than B into C, then A by B is greater than C by D. That is, A is to B is greater than C is to D. If A into D is smaller than B into C, then A by B is smaller than C by D. That is, A is to B is smaller than C is to D. If A into D is equal to B into C, then A by B is equal to C by D. That is, A is to B is equal to C is to D. Now, can you tell me which ratio is greater? Right, 18/25. If A and B are two positive integers where A is greater than B, then determine the order relation between A by B and A plus M by B plus M, where M is a positive integer. Now consider A by B minus A plus M by B plus M. If we cross multiply, we get AB plus AM minus AB minus BM upon B into B plus M. Now cancel AB. We have AM minus BM upon B into B plus M. Now take M common. We have given A is greater than B. Therefore, A minus B is greater than 0. M is also positive. Therefore, M into A minus B is also positive. Therefore, M into A minus B upon B into B plus M is positive. Since B into B plus M is positive, the answer of A by B minus A plus M by B plus M is positive. Hence, A by B minus A plus M by B plus M is greater than 0. Therefore, A by B is greater than A plus M by B plus M. Hey, all of you understood what I taught? If you understood everything, let us turn to properties of equal ratios. Now, first property of equal ratio. If A by B is equal to C by D, then B by A is equal to D by C. The property says, if we invert both ratios, the ratios we get are equal to. Now, this property is called invertendo. Now, second property of equal ratio. If A by B is equal to C by D, then A by C is equal to B by D. The property says, if we interchange denominator of first ratio with numerator of second ratio, the ratios we get are equal to. And this property is called alternando. Now, student, third property of equal ratio. If A by B is equal to C by D, then A plus B by B is equal to C plus D by D. The property says, in both ratios, if we add denominator to numerator, the ratios we get are equal. And this property is called componendo. Fourth property of equal ratio. If A by B is equal to C by D, then A minus B by B is equal to C minus D by D. Now, the property says, in both ratios, if we subtract denominator from numerator, the ratios we get are equal. And this property is called dividendo. Fifth property of equal ratio. If A by B is equal to C by D, then A plus B by A minus B is equal to C plus D by C minus D. The property says, in both ratios, if we add denominator to numerator and write as numerator of new ratios, then we subtract denominator from numerator and write as denominator of new ratios, and the new ratios we get are equal. This property is called componendo dividendo. Theorem of equal ratios. Students, now let us learn theorem of equal ratios in easy way. Let us take three ratios: 3 by 6, 4 by 8 and 5 by 10. The ratios are equal to 1 by 2. Now take any three non-zero numbers, 5, 11 and 7, and multiply with numerator and denominator of ratios respectively. Add numerators and denominators of ratio. And did we get a ratio after sum equal to 1 by 2? Yes, it is. In general, if A by B, C by D and E by F are equivalent ratios and L, M, N are non-zero numbers such that LB plus MD plus NF, etc. is also non-zero, then if we multiply respective non-zero numbers with numerator and denominator of respective ratio, the ratio of sum of numerators and denominators is equal to each ratio. Therefore, LA plus MC plus NE plus etc. by LB plus MD plus NF plus etc. is equal to A by B is equal to C by D is equal to E by F. Students, let us learn now proportion. 5 by 10 and 60 by 120. Now, are these ratios are equal? Yes, because if we cross multiply, the ratios we get both the sides are equal. Here, numbers 5, 10, 60 and 120 are said to be in proportion. In general, if A by B is equal to C by D, then the numbers A, B, C and D are in proportion. Numbers A, B, C and D are called proportionals. A and D are called extremes and B and C are called means. Observe these equal ratios. In the ratio, we can see that denominator of first ratio is numerator of second ratio and so on. Therefore, A by B is equal to B by C is equal to C by D. Then, A, B, C are said to be in continued proportion. The sign shows continued proportion between ratio of A and B and ratio of B and C. Now, if we cross multiply the ratios, we get B square is equal to AC. B is called geometric mean or mean of A and C. Here, we can say that in continued proportion, the product of extremes is equal to the square of the mean. Summary. In this subtopic, we have seen introduction of ratio, order relation between ratios, 5 properties of equal ratios, theorem of equal ratios, proportion and continued proportion. So that is all in this subtopic. We will learn variation in our next topic. Till then, keep learning.